This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data with GenAI. Friends, in previous session we are going through with the transformer architecture, and from the transformer perspective we are having details like how the parameter size is being created in the transformers. What is the meaning of this? Say if we are passing certain information and what exactly transformer is doing, it is able to predict the next word. What is the meaning of this? Say if I'm going to pass like uh, say Sachin is a and is a, and if I'm passing this particular sentence, then it will able to predict cricketer. Okay. Okay, so it will be able to predict cricketer. So Sachin Tendulkar is a cricketer. So how does it is being happening that we are going to understand? And from this in this direction, what we have seen, we have gone through with this particular tutorial, and in the beginning, what we have seen, like if we are having say age and gender. Over here I have given the example. Say if I'm having certain words, say man, the gender is there and age is there. So uh, we will be able to plot it into in terms of say 2D array, 2D matrix. Okay, and once we are able to convert it into the matrix, then with the help of Euclidean distance we will be able to measure the distance. Okay, so measuring distance is the stuff like by which we will be able to get the similarity. Okay, lower the distance, more the similarity, and based upon this the weight is being given, and the weight is being, you can say, refined in order to get the correct word. Okay, so over here in this particular, you can say, transformer architecture, we have discussed the two mechanism, attention and MLP. Okay, multi-layer perceptron, that is feed forward layer. So attention mechanism. So over here, if you are able to see, these are nothing but the vectors. Okay, vectors. So these vectors are talking to each other in order to get the predicted word. Predicted word with respect to certain probability, and how we are able to calculate the probability based upon the Euclidean distance. So let me show you. This is the stuff what we have seen in our previous session. Okay, so say these are the keywords: man, king, king, man. Okay, woman. So we have calculated the distance. Say if man is a king, then woman will be queen. So based upon the distance, we will be able to get the outcome. And this is like how the mathematically things are being happening once we are talking about the transformer architecture, and this is the main building block for the Gen AI. Moving further, so over here, like we have seen the matrix formulation. Okay, say if I'm having a particular sentence, we can take this one. Okay, if I'm having this particular sentence, then what will happen? This particular sentence will be converted into it will be encoded, and we will be having the encoded outcome. And the encoding mechanism, there are different encoding mechanisms are there. Okay, so once this encoding is being is you can say closed, once the encoding is performed, then it will move with respect to the distance calculation. And we have seen, yeah, Euclidean distance. This is the formula in order to calculate the Euclidean distance. Like if we are having two vectors x1 and y1 and x2 and y2, and if we are going to calculate the distance, this is with respect to x direction, this is with respect to y direction. You can take it in this particular way. Okay, let me show you. The 3D chart I just want to show you. Okay, so this is the 3D chart, like we are having x, y, and z direction, and with respect to, say, this is the like if this is we are talking about the boy, then it will be having this much of distance from girl, this much of prince, this much of man. Okay, and like we will be having x, y, and g coordinate. But this is with respect to three dimensions. Once we are taking three features. Over here we are taking the three features, that is gender, age, and royalty. Okay, this is royalty, this is gender. Okay, and this is age, and this is the gender. So we are taking three main features, and with respect to this the calculation is being happening. Now if we are talking about the 2D, two dimension, then the formula will be like this. So we are going to calculate the Euclidean distance between the two vectors. Now, friends, the Euclidean distance is going to provide the the distance between two vectors, but there is certain issue with this particular calculation. Now just let me try to repeat what I we have done so far with respect to the word embeddings. So I have taken the example of two features and three features with respect to some words are there, like man, woman, kid, uh, child, girl, boy. So these are the certain words that I have taken, and I have done the calculation based upon the features. So I have gone through with three features: gender, age, and royalty. But in the actual world, there are lots of features. If we are talking about Chat GPT, GPT-4 model, it is having 12288 features. 12,288 features are there. And what is the meaning of this? Like if I'm having a word, if I'm having say man, okay, then it will be having, this man will be having 12288 values with respect to man. It will be having the 12288 values. Okay, so that is like how the embedding matrix is being prepared. If I'm having say vocabulary size 50K, then what will be the matrix size? If I'm having the vocab size 50K and 12,288 features are there, what will be the matrix size? Guys, what will be the matrix size? Anybody? What will be the matrix size? Lakshmi, what will be the matrix size? Tejas, Rohit, anybody? Neha, what will be the matrix size? Okay, let me explain. And guys, just pay attention. Okay, so what is being happening? Say if I'm having uh, Let me start just from the base. So what is there? We are having scalars and tensors. Okay, we are having scalars and tensors. Just forgot about what I was asking. Just I'm going to start just from the beginning. Okay, so a scalar is nothing but let me talk about first tensors. So in the GenAI world, uh, we used to describe the things with the help of scalars and tensors. Okay, let me quote with the help of certain practical stuff. Then you will be able to get in a better way. Okay, so I'm having this particular uh, Jupyter notebook file. Okay, so over here we have gone through with importing the different large language models and perform different tasks. Let me take an example like this is POS Finder. Okay, and this was the model which we have used, and then this is the content, the POS text, and it was given. And similarly, like if we were willing to translate something, okay, into the different language, so over here the translation has been done. This is done with the help of this particular translation model, translator text, and I think this is French conversion, French or Russian conversion. The model trans Gen AI. Okay, so this is the translator. The task is translation over here, and English to Russian conversion. This is the model which we have used. This is for the translation task. In the same fashion, like we have performed the multiple tasks. Say the translation is one task, the question answering is the another task. What we have performed, sentiment analysis we have performed, and what we have done with respect to these particular tasks, we have just imported a particular model, and the model is able to perform a specific task. The default task is being performed by a model, although like a model can perform the different task, but it is meant for certain specific task that is the default one for that particular model. So we have done different things, say sentiment analysis, question answer, one language to another language conversion, then feature extracting, and all these particular things we have done with respect to the certain models. Okay, and it was fine. Now there are certain internals with respect to these particular models. Let me show you. So I'm having a model, say feature extraction. I'm having a model feature extraction, and I just want to extract some features, and then will provide you the understanding about the tensors and all. Okay, so from transformer, and I will import the pipeline. Okay, and then feature extraction, I will use a feature extractor, and what I will pass the pipeline, and I will use the task that is nothing but feature extraction. Task is feature extraction. This is the task what I want to perform, and say model I will use Facebook BART based model. Model equal to Facebook BART base. This is say model what I'm going to use. Let me try to run. If things are fine, it will be success. Okay, so device is set to CPU, like I'm able to have the execution of this. Then moving further, what I will do, I will have certain text, and from this particular text I will be trying to extract the feature. And let me take our example, or let me do say booster analytics is providing GenAI course. Okay, let me do the execution of this. So I'm able to have the execution. Now moving further, what I will do, I will try to pass this particular text from this pipeline, and I will try to get the features. I just want to extract the features. Okay, so what I will do, I will be having say result, and I will be having this feature extraction, that is the pipeline what I have built, and I will pass this particular text, okay, from this feature, and then I will try to print the result. Okay, print the result. So it will extract the features from this particular uh, given, you can say, text. So this is the text what I have given, and it has extracted these particular features. Okay, so that is fine, like it has extracted the features and all. But what I want to show, I just want to show this particular stuff we have seen in our previous session. Up to so far we have seen in our previous sessions, but what I just want to get the understanding about tensors and all. Okay, now what I will do, I will do a little bit more and return tensors. Return tensors, and it will be equal to say pt, and that is fine, and result dot shape. I just want to print the result as well. Okay, so BART model, just try to understand. Over here, 1, 2, 3, 4, 5, 6. Okay, so over here, what I'm having, just try to focus. So once the the encoding has happened, okay, the encoding has converted this boost analytics is providing GenAI courses into 10 tokens. Okay, let me try to mention it. Just pay attention guys over here. Pay attention. So boost analytics, now the encoding happened. This is the very first step, encoding, and it has converted the given sentence into 10 tokens. Okay, 10 tokens. Now if we are having this particular, it might be possible like say booster analytics s is provide ing, okay, gen and ai and course. Okay, it might be possible it has taken into different way and it has converted into the it into 10 tokens. Okay, now we are having 10 tokens. Now, what will happen? This BART model, this Facebook BART model is having 768 features. Okay, it is having 768 features. 768. 768. Okay, so I am having say 1 cross 10, that is one. I have provided just one sentence, 1 cross 10 cross 768, 768, okay, 768. This is nothing but the features what I'm having. Okay, now these particular 10 tokens, 10 tokens are will these particular 10 tokens will be having 768, you can say, different words with respect to 768 values with respect to the each one. Just have a look over here. Okay, so 1 2 3 then 10, and over here this will be, you can say, 768. Okay, so say over here, say booster, I'm going to take the booster. So say booster is there, and one feature is say you can take, say booster is there, and one feature you can say age is there. So with respect to the age, it will be having 768 values. 0 0 1 2 3. I'm taking hypothetically. Okay, so it will be having these particular values. Okay, and how these particular values are generated based upon this particular calculation what we have seen. Over here what we are going to perform, say if we are taking only say boy, girl, man, woman, these are the four, you can say, words we are taking, and we just talk about the two features, gender and age. Okay, gender and age. So with respect to say these particular four words, boy, girl, man, and woman, we will be having the matrix. It will be like say boy, woman, boy, and man, woman, boy, and girl. So we will be having the matrix, uh, 2D matrix. Okay, and in this particular 2D matrix, like we will be having two-dimension matrix, and we will be having four rows and two columns. Four rows and two columns. In the same fashion, what we are having 10 rows. 10 rows, just forgot about this particular one. So what we will be having, 10 rows and 768 columns. 768 columns. With respect to each and every, you can say, word, we will be having the different values with respect to say different words. Say this particular booster will be having the different value with respect to age. You can take it in this particular way. If age, with respect to age, it is having different value. With respect to uh, say royalty, I'm taking it hypothetically, royalty, it will be having say different value. With respect to say classes, it will be having say different value. Okay, so in this particular way, one word, okay, one word will be represented by 768 768, you can say, columns. So it will be having 768 values because we are having feature size 768 in the Facebook BART based model. But once we are talking about the GPT-4, So it is of 12288 dimension. Okay, 12288 dimension. What is the meaning? Each token will be having 12288 values. Are you able to get all of you? So tensors and scalars. Huh? So tensor from the GenAI perspective, we used to say data structure. Huh? Data structure, and it will be utilized to present the information numerically. Okay, so tensor is nothing but the data structure, and you can say multidimensional array. Multidimensional array. And what is scalar then? Scalars are nothing but a single numerical value. So if we are talking about say this is a tensor, like we are having the matrix of 10 cross 768. So this is the matrix what I'm having. So this particular matrix, in say this is a scalar, this is a scalar, this is a scalar. So each you can say value, single value is a scalar. Scalars, combination of scalars create the tensors, and tensors are nothing but the data structure which is being utilized inside the GenAI world to represent the information, to represent the data. Okay, so what we are able to get over here, this is nothing but tensors. Okay, and the size of this particular tensor is 1 cross 10 cross 768. 768 is nothing but the feature size in BART based model. 768 is nothing but the feature size, number of features, and 10 is nothing but this particular given sentence is converted into 10 tokens, and these 10 tokens will be having 768 values each with respect to the context and all. Okay, clear so far, all of you? Scalar, tensor, is it clear? And how we are able to get the matrix from a given sentence? Are you able to get, friends? Any
Sir,
confusion so
please
far?
tell me again, tensor.
Okay. Tensor is nothing but a data structure. If we are having, if we need to represent something inside the GenAI world, so it will be
Okay.
represented in terms of matrix, and this matrix is nothing but say the combination of row and columns, and once like we are having the representation of data in numerical format, then we usually say tensors. This is nothing but multidimensional array.
Okay. Thank you so much.
Multidimensional
Thank
array.
you, sir. Okay.
Okay, and each unit, each you can say value inside the tensors is called scalar. Okay, or you can say tensor of rank 0. Tensor of rank 0, that will be a scalar. Like if you use to represent 2.723, that will be nothing, that is nothing but scalar. Okay, okay, so tensor
Sir,
and
one thing.
scalar, yes.
Sir, 10 is representing as the column. Okay, just like it's the token, and 768 is the dimension. So, what one is representing there?
One is nothing but this one sentence is converted into 10 columns, and 10 columns further mapped with 768 dimensions.
Okay, sir.
We will,
Okay, got it.
okay.
And one more thing, sir.
Mhm.
We are performing various tasks by utilizing a particular model. Okay, so I hope there are hundreds and thousands of models present there. So we need to memorize all the models to perform the specific task.
No, no, no. You need to memorize the task what you are willing to perform. With respect to your task, there might be hundred of models. Okay, with respect to task, a task can perform hundred of tasks, but with respect to your specific task, there are specific models. Be specific. Okay, try to focus. With respect to your task, there are hundred of models, and you need to check with different models with respect to the accuracy and all. Some models are based upon, say, you can take it in this particular way. I'm having this particular model, Facebook bart based model. Okay, we are having Google bart based model as well, huh? We are having llama model as well. We are having GPT models as well, huh? Okay, so different models are there which can perform different tasks, but with respect to your task you need to identify specific models. You need to go through with those particular models, test with the accuracies, and it might be possible some models are trained based upon your organization data. Okay, and some of the models are trained onto specific, or you can say general data, or the data that they found onto the internet, huh? So some of the models might not have the data with respect to your organization, and once you are going to do the do once you are going to apply those particular models, you will not be able to get the correct outcome, right? Whatever we are
Yes,
getting,
sir.
that is based upon the training, pre-training, what is being happening. Okay, now, and another thing, one is the data on which the model is pre-trained. Second one is the parameter size and all. Okay, so say models are having this 768 dimension, will be having the lower accuracy if we are comparing with the 12288 12,000 288 dimensions. If we are talking about 12,288 dimensions, and if we are comparing it with 768 dimension, then obviously we will get the better accuracy once we will go through with the part model, huh? Oh sorry, this GPT-4 model, huh? Because that is having higher vocab size and higher the dimensions, more the features, right? So this 768 or the 12288, that is representing the features. Now booster is a keyword, and that is from this particular sentence. Now it will be having 12288 values with respect to the GPT-4 model, and once it is there, once it is utilized with the BART based model, then it will be having 768 values. Okay, so, or in another words, you can say one one token. Just pay attention. One token will have multiple features based upon the model utilized. Based upon the model utilized. If Booster is using BART based model, let me write it. If Booster token is using BART based model, then it will have 768 values, or features, what I can say in a specific term. It will have 768 features. And if booster token is using GPT-4, then it will have 12288 values, and 12288 values, these are nothing but the features, huh? Now if you are having 10 tokens, okay, if you are having 10 tokens, 10 tokens, then you will have 10 cross 12288 matrix. Okay, then the matrix size will be how much? 10 cross 12288. Clear so far? Are you able to get, all of you, the same stuff what
Yes.
we are able to see over here? 10 cross 768. Okay, this is the matrix size over there, and 10 cross 12288 once we are using the GPT-4 model. Now you need to tell me, if I'm having 50,000 token in a model, if I'm having 50k tokens in a model, then what will be the matrix size?
So
What will
50K
be the matrix?
into 2288.
Yes, 50,000. Let me write it down. 50,000 cross 12288. And if we multiply 50,000 cross 12288, okay, it will be 6144 and 5 times 0. Or in another words, what it will be? Around 600 millions, right? Fine so far? 600 millions parameters are there in the embedding matrix. This is nothing but called embedding matrix. Now let me come on to the point. So this matrix is being prepared, and why we are preparing this particular matrix? In order to calculate the distance. In order to calculate the distance, and Euclidean distance was utilized in order to calculate the distance. This was giving the distance in a perfect way, but in order to find out the distance for the word embedding, this is not the preferred criteria, this is not the preferred stuff. Okay, so this metric preparation and distance calculation, this Euclidean distance was providing the correct output, but this is not preferred for measuring the distance for the embedding matrix. It has been written over here. Is perfectly reasonable distance measure, but it is not preferred distance to measure the word embedding. Okay, this is nothing but the word embedding matrix what we have prepared. So Euclidean distance is not the preferred way. Now the another way to calculate the distance between the vectors is nothing but the dot product. Okay, now so dot product is proportional to cosine of the angles between the two vectors. This is nothing but the definition of dot product. And like if we are having this particular word and we are having x and y dimension, and these are the values with respect to x and y. So how we will be able to calculate the dot product? First, we just need to find out the mean of x, mean of y, and then we will proceed with the mean vector. So mean is 4.5 for x and mean is 4.625. I have done the calculation. If you are willing, we can do it once again, but I have done the calculation in advance, so you will be able to consume the content. So just I'm willing to perform the dot product for this particular matrix what is given over here, and x is taken and y is taken, mean has been calculated. Now what I will do, I will perform, just a minute. Okay, then what I will do, I will I will subtract this particular mean from the original value. Say one was there, with respect to grandfather, one was there, and if I subtract it from the 4.5, so it will be minus 3.5. If I subtract it from the 9, it will 9 minus 4.625, so it will be this one. Okay, in the same fashion, like I will be having I will do the subtraction for each and every vector. Okay, now this is nothing but, say, the dot product have been calculated, but this dot product is also having some issues. We have gone through with initially we have gone through with the Euclidean distance. Euclidean distance was not utilized for the embedding matrix. Now we have moved with the dot product. So dot product has given this particular matrix. Okay, we are able to get these particular values. But once we are going through with this particular calculation, then it is having the certain issues. So what we have seen, the dot product is proportional over here. It is proportional to cosine angles between two vectors. It is proportional, not exactly the same, not exactly the equal. Okay, so proportional to cosine angle between two vectors, that is the main challenge once we are using the dot product. So dot product was having this particular issue. In order to tackle this particular situation, then what we are having, we are going to calculate the unit vector. Unit vector, in order to calculate the unit vector, what we are going to do, this is the formula, like if x and y with the length u, then we are going to find out the square root of x2 and y2. Okay, and then what we will do, we will do, say, over here, this is nothing but the magnitude calculation. Okay, so say this is 3.5, and with respect to the magnitude of x and y, so the magnitude is calculated in this particular way. Okay, you will be having, say, x divided by this particular square root of x2 and y2. Okay, let me try to show you how this particular calculation is being happening. Okay, so once we are going to calculate the unit vector, what I have mentioned, the vector is having the issue because the outcome what we are getting, that is proportional to cosine angles between two vectors. It is not exactly the same cosine angles between the two vectors. It is not exactly the same, but proportional to. So in order to remove that particular issue, what we are going to do, we are going to calculate the unit vector. Okay, so in order to calculate the unit vector, say we are having an x and y, and in order to convert it, this is the formula. Say original values are 3 minus 3.5 and 4.375. This is the value, and we will be going to calculate the magnitude of these particular values. So we need to do the square root. We need to scare it, and then we need to find out the square root of these particular values. So it is like proportional to 5.6. So over here, what we are able to see, this is nothing but 5.6 is the magnitude of these two values. And once we are having this particular magnitude, then what we will do, we will find out, we will divide these particular component in order to find out the unit vector. Okay, so say these are the two values, we will divide it with respect to say 3.5 divided by 5.6 and 4.375 divided by 5.6. So we will be getting these particular values. Okay, so each value will be divided by the unit vector, then we will be getting these particular values. Okay, now this is nothing but the unit vector, and the unit vector and the dot product, the both of these are giving almost the same values, but these are not identical. And what is the meaning of this? Just have a look over here. Just have a look over here. Okay, so over here, say if we are having if we are going to calculate, if we are going to calculate the distance, the distance from boy, child and infant. So this is the boy, and this is child, and this is infant. Okay, so boy, child and infant, once we have gone through with the dot product, so dot product, what it is saying, say boy is having the infant is onto the higher angle with respect to the child. This is the boy, this is boy over here, and if we are going to calculate the angle between infant and child from the boy, so the infant is onto the higher angle, right? Infant is onto the higher angle, and this is this what we got with respect to the dot product. And from the Euclidean distance, what we got, like boy is there, child is there, infant is there. Okay, so we got almost, you can say, the same, but this particular stuff is not utilized, not preferred for measuring the distance for the word embeddings, Euclidean distance. So dot product was used. With respect to the dot product, we got, say, boy, child and infant. These are having the infant is having more distance with respect to boy. But once we apply the unit vector, once we apply the unit vector with respect to this, so the boy is there, a boy is there over here, and then child and infant. So infant is having a little bit, infant is closer to boys with respect to the child. Okay, although like there is no major variation is not there, but the unit product of uh, unit vector is going to, you can say, provide, and all of these particular values are, you can say, between 0 to 1 only. 0 to 1 only, uh, bit you can say minus 1 to 1. Okay, so over here, this is the way like how we are able to get the values, and we have used the unit vector over here in order to calculate the distance. So once, like say if we are going to calculate, say a boy, say the man is tends to the grandfather, then woman will be tends to, you can say, the grandmother, probably it will be over here. Okay, or the boy is, you can say correspond to man, then the girl is corresponding to woman. So we will be able to find out the distance between distance, and with respect to the distance and all, we will be able to get the probability, and that particular probability will be acting in order to provide the outcome. How that, with the help of the transformer architecture, we will be able to predict the next word. Okay, how with the help of the transformer architecture we will be able to predict the next word. So this is the maths behind the transformer architecture. It is not over yet. We will be having the different things as well with respect to this particular internals, what is being happening. Although, like, these are not the this is not the mandatory stuff, huh? These things what I'm going to cover, this is not the mandatory stuff. Like, it is just to provide you the internals, how the things are happening. I have gone through with the easy examples and all, but you will never be able to get how the things are happening internally, yeah? Okay, so that's why, like, I am having focus with respect to the maths, like why we need to have the dot product, why the unit vector is taken. Okay, what is the betterment that is given by the unit vector instead of the Euclidean distance. Okay, and why this particular measurement is being happening, why these calculations are being happening, huh? So this is what we are able to get based upon the mathematical calculations and all. And you can think, uh, if we are having the matrix which is having this particular size, okay, say 50 crores, 50,000 crores, 12288, so this requires a lot of computation stuff. This requires a lot of computation stuff, and without the GPUs that is not possible. Okay, so the GenAI, if we are talking about the GenAI, why it is success? Because of the transformer architecture that we are learning, and another stuff, the GPU architecture. If we are dealing with CPUs that is having the limited processing capabilities, so we will never be able to get the outcome. So CPUs, uh, from the learning perspective, those are good. We will be able to learn the things, but in the GenAI world, actual stuff is being happening onto the GPUs. And there are another opinion as well. Opinion with respect to, say, if we are going to utilize the pre-trained models, then that is fine. Okay, at that moment there is no major need of huge infra. But if you are looking for pre-training the things, the stuff what we are doing, that is being happening during the pre-training phase. Like, if a particular sentence is there, how these particular word embeddings are being happening and all. So, and initially, like, if we are having huge amount of data, and based upon that we are going to perform the pre-training, then huge infra is required at that moment. Okay, so we have seen this particular stuff. This we have seen. Okay, so the outcome with respect to the outcome, like why dot product is preferred uh, with respect to the Euclidean distance. Okay, Euclidean distance. So first, like, the number of calculations are less inside the dot product. If we are talking about 300 dimensional vector, 300 dimensional, like we are taking 300 features. If we are having 300 dimensional vector, then how many calculations are required? So 519 in total, we will be having 899 operation. 599 operations with respect to say multiplication and addition, and 300 subtraction. These are the number of operations once we are having 300 dimensional array, 300 dimensional vector. Okay, and once we are this is with respect to the this is with respect to you can see Euclidean distance, but once we are using uh, the dot product, it will have only 599 operations. 300 less operations are there once we are using the dot product. That is mentioned over here, like dot product requires 599 operations, 300 multiplications, and 299 additions. But once we are talking about Euclidean distance, then we will be having the 899 operations in total. Second, the dot product is exactly what neural networks are using. So inside these particular things are being processed with the help of neural networks. So neural networks are using dot product instead of Euclidean distance. So that's why like this is better if we compare it over Euclidean distance, the dot product. Although like the results we have seen, the results are almost the same, but not identical. Okay, not identical. Boy is slightly closer to child than the infant. The angle between boy and infant is slightly less than. So over here we talk about the distance. Over here we talked about the angle. Okay, so let me repeat it once again. So what we have seen in today's session, friends, we have seen like how the tensors are being generated, and with the help of the tensors, how the matrix is being prepared. So if a particular model is having, guys please go on mute. Guys please go on mute. Was speaking, I think. Okay. So if a particular sentence is given, then it will be converted into tokens, and those tokens will be multiplied with the number of dimensions. Say if we are using BART based model that is having 768 dimensions, and what is the meaning of that? Like it is having 768 features. Each token will be having 768 values, and how these particular values are calculated based upon the pre-training and all. Then inside the transformer architecture, these tokens will talk to each other. Okay, the talking to tokens is nothing but we are going to identify what will be the suitable distance with respect to this. So let me try to explain it over here. Say Sachin is a, and we are having this blank value. Okay, so
Sir, I have a question.
mhm.
So just like in BART model, there are 768 dimension, and if you're talking about the GPT-3 or 4 model, it's the 12288 dimension. So
Mhm.
it also affects the that's the foundation model or the base model as according to the dimension that if the dimension is high, so it is more accurate, or BART is not accurate as compared to the GPT-4 or 3, just like that.
Definitely, but some models are pre-trained with respect to a specific task. Okay, and the tokens or vocab size, what a model is having, that will be depending upon the data which is passed. Okay, more the tokens and more, like we will be using sophisticated uh, programs in order to calculate that this is the data I'm having, say 100 terabyte data, 100 TB data is there. Okay, and then tokens are, we try to identify the tokens. Okay, based upon these particular tokens, what we will be having vocab. Okay, now vocab from this particular vocab, in order to, you can say, organize what we will be having the features. Okay, like these are the features. Say if I'm having let me take, say, banana, orange, orange, pumpkin, and say pumpkin and watermelon. Okay, so I'm having, say, these four words, and I'm having, say, fruit, and say vegetables. Okay, so say I'm having these particular 3 and 3 6 words, and say this is the vocab for me. This is the vocab. Okay, this is the complete vocab. Now if I want to create the features, what I will do, I will try to have two features only. Okay, that is a fruit and vegetable. Just try to think. So we will be having sophisticated programs, okay, specialized programs, which will consume this particular data, convert it into tokens, create a complete vocab size, and then they will identify that we can fit this particular data, 100 terabyte of data, into these particular features. Then we will be having 12288. Okay, say over here we have used only 100 GB of the data, so based upon that am having 768 features. Okay, so in this particular way, the the features are being calculated, being, you can say, find out, and based upon those particular features, I will be having the dimensions. What I can say, the dimension for this particular matrix. Is it fine?
Yes, sir. And one more thing, that if any model have the larger dimension, so according to me, it will take more time to perform any task as compared to the less dimension models.
Obvious, obviously, because it need to pass with, it will be having the huge amount of calculations. Over here, if I'm having this particular model, which is having, say, two features, the matrix size, what it will be, say if I'm having 6 tokens, 6 cross 2 matrix will be there. Over here, if I'm having 10 tokens or 6 tokens, so 6 cross 6 cross 12288, or 6 cross 768. That will be the matrix size, and you can understand, like if we are having this particular matrix which is having the bigger size, definitely it will take more time in order to have the calculation. And even like the pre-training of this will take, say, months, it may take weeks, or it might be possible the pre-training with these particular two features can be completed in, say, 1 hour, right? Things depends upon the data and all.
Yes, sir. Got it.
Okay, so so the dimensions are depending based upon the model, and how these particular dimensions are calculated based upon the data which is utilized in order to pre-train the model. Then tokens are identified, tokens depending upon the scheme, which algorithm is being utilized over here. Okay, so inside the
On the previous note, like, can we say if for any of the model we have to compromise at one level or the other, like whether it is related to the feature or it is related to the execution speed?
both are execution speed. So depending upon the infra, what they are going to utilize. Okay,
So is
so
there is a optimized way where we can get all the parameters or every what you can say every element of that process to be in a precise one, like the best model, best parameters, and best execution speed. Like how we can achieve that.
so so that will come with benchmarking only, yeah. Okay, until unless with the specific data that you are having, you are not exploring the models post applying it, then you will, till then you will not be able to get, you need to do the benchmarking. And it might be possible, say, I'm having, at this moment I'm having, say, GPT-4, GPT-4 model is there, and uh, it was uh, it was trained on to, say, 100 TB data. Okay, I'm taking it hypothetically. So GPT-4, it is trained onto, pre-trained onto the 100 terabyte data, and you are performing, you are trying to get the outcome. So you are having your organization data that is of, say, 1 GB, and you fine tuned this particular GPT-4 model with respect to your organization data, and say you are able to get some accuracy. Okay, uh, we we are going to utilize the model in such a way that it will not hallucinate. So the one problem what is there inside the GenAI or GenAI models, it will start hallucinating if we are not providing the correct prompt and all. So it will hallucinate. So how we will be able to improve that, that is one stuff. Then uh, then how we are going to provide the prompts and all in order to get the outcome from these particular models, that is depending upon the data and all which is utilized in order to pre-train. So what I have mentioned, say, 100 TB data was utilized in order to pre-train, and it is, say, providing the outcome with respect to your organization data. That is fine. You can say over here we are not talking about, say, the accuracy and all, or the probability and all. We say it is providing the expected outcome what we were requesting now. But after some time, then GPT 4.2 is there. They have used, say, 1000 terabyte of the data, and now the organization has mentioned that you need to opt 4.2. Okay, and it will be providing the more accurate outcome. So previously the hallucination was there, say, once that the model was trained onto the 100 terabyte data, and it was not able to provide the correct outcome, and it was start hallucinating at that moment once we are asking certain weird questions which are not there inside the the training data set, 100 TB data set. But now 1000 terabyte is utilized and GPT 4.2 is there, then the model start giving the correct outcome. So uh, so if a model is if a model has started hallucinating, then there are the different ways. in order to tackle. Either you need to provide the correct prompt, or you need to have certain conditions that it will not be providing the incorrect output. You can restrict the GenAI model in order to provide the weird output. Okay, it might be possible. If you have seen, once the this Gemini was launched, so it was not able to provide the outcome. Say if user was mentioning, say, add 1 plus 2. Okay, so it might be possible it was giving the outcome 4. Okay, but then they have identified this particular stuff. This was the problem. Once the GenAI was launched, initially it was launched with name Bart. Okay, and then they have refined this particular stuff, and then after few days this issue was resolved. So now coming back to the point. So in order to get the performance from a particular model, which is say limited to 100 GB data, so it is not like you are going to perform the pre-training and all. It has been done. What you can do the fine tuning. So fine tuning you can do in order to have the better accuracy. Fine tuning, then then providing correct prompt. Okay, so you can get the outcome. There are a lot of things as well, but I'm not going in detail at this moment. So fine tuning, post, you can say, pre-training phase fine tuning is there. Better fine tuning you can have. And then the providing the correct prompts. It is like, say, sometimes this has happened to me. Okay, month id was there. Month id was there in data as column name. Column name, and I was giving month plus id. Month plus id. Okay, so then the the GenAI model, what it was taking month id, month id plus id. Okay, and it was throwing error that that uh, month id plus, it was doing month id plus month id. Yeah. Okay, so instead, with respect to month, it has taken the month ID, and with respect to ID, it has taken the month ID. But what I was expecting, month ID and ID was different columns. So month ID and ID was different columns, and I want to have this particular outcome from the GenAI model. Okay, but it was providing month ID plus month ID. So either like I should have passed the correct column names like month ID plus ID. Over here ID should be there, or then certain fudgy logics are there what I can apply onto the column name. Say if you are typing something onto the amazon.com, amazon.com. So if you are willing to purchase a iPhone, okay, iPhone, and if you have written I, okay, okay, so if you have written this, so it will take it iPhone only. Yeah. Okay, over here like one or two letters it is going to check, and the fuzzy, based upon the percentage of fuzziness that you can have, say 50%, so it will correct, and it will convert this incorrect word to the correct one. Say 50% fuzziness is there, and then what it will give, it will provide the outcome with respect to the amazon.com only. Now you need to provide the correct prompt. Over here, the GenAI model was not giving the correct outcome. We are talking about how we can improve the accuracy and all. Okay, with respect to the limited infra and time. So over here, we are consuming, we are consuming the pre-trained model. We are not building the models at this phase. So with respect to the limited infra and all, like based upon that, say if we are using, say, uh, GPT-4 model as as a foundation model, and on top of that we have done the fine tuning and all, and say the data size is 50 GB or 70 GB, and the base that 70 GB you are going to use in order to get the outcome based upon your data. Say you are passing something, you are asking queries to the GenAI, then the infra that you are going to utilize, that must be capable to handle that much of, you can say, data, say 50 GB, the base file. Now the question based upon how many users are there at a time. So if more users are there, then and they are performing the simultaneous operations, then you need to do the infra calculation with respect to that in order to get the outcome. So over here we are utilizing the model, okay, but the pre-training and all those particular things has already done, and huge infra is required at that moment in order to have the pre-training. Okay, pre-training, once the pre-training is done, then we will refine the or we will, you can say, keep on refining in terms of, you can say, do the fine tuning and all, and that requires the small amount of infra. Okay, so infra is not a major challenge with respect to the fine tuning phase. Okay, we can have small amount of infra, but that will depends upon the data what you are having. Over here I have taken, say, 1 GB data, and I want to fine tune based upon this particular model based upon 1 GB data. Okay, what I'm having, inputs or prompts, this fine tuning have different, you can say, phases. So this fine tuning based upon what, like, say, sometimes I can do the fine tuning based upon, say, 10 questions only. I will ask the questions to the GenAI model and proceed with the fine tuning, and I can say, do I can ask 100 questions, or I can ask thousands of questions. Like I'm going to train the Gen AI to provide the correct outcome. So that fine tuning will be decided by us only, like what will be the complexity of that particular fine tuning. So from the accuracy perspective, the time perspective, and the cost and all, so these particular things are having certain deciding factors. Fine, pre-training we are not doing. Okay, pre-training can be, if like someone is willing to perform the pre-training, then based upon the the data that they are going to consume, it might be possible, like they are going to use all the wikis and the internet available data, organizational data, personal data, data from the government, data from the news portals and all. Okay, if someone is going to utilize that particular stuff, then definitely they need to have huge infra, and it will take months of time. If they are going to minimize it, then they can reduce either the data, they can either, or if they are willing to complete it in a fewer days, then they can increase the cluster size and all. So those particular things are there with respect to the pre-training. Fine tuning, the output that you are getting, based upon that you need to perform the fine tuning. Now over here infra will be depending upon the number of questions that you are going to ask, the initial data that you are having. Okay, that based upon that the time, complexity and cost can be calculated. I'm talking about something like benchmarking related stuff. Moving further, once the the model is pre-trained and fine-tuned, now it's the time to utilize that particular model. Once it is the time to utilize the model, then the infra that is depending upon how many users are using simultaneously. Okay, that is the deciding factor in order to have the infra. Okay, second, how fast you want to have the outcome. Previously we have observed that chat gpt was keep in hanging state. It was not able to provide the outcome. Before 2 months, uh, I think Giblify was the stuff onto the chat GPT, and all of the users trying to convert the images into the Giblified images. So at that moment the server was, you can say, chalked, and users were not able to get the outcome. This is with respect to the users, what they are having, and the task they are going to perform. Okay, uh, it might be possible like one model is designed to perform the different task. Okay, but how it is being utilized inside the industry, say the industry is using all the features from the model, or they are using the specific features from the model, huh? So based upon that as well, the cost, time, and the users, okay, will infer the things and all. Another thing, like if you are working with an organization which is, you can say, doing the stuff like the fine tuning of the GenAI models, then also like the cost, infra, these particular things are considered, huh? Then coming back to the point with respect to the outcome, huh? So the GenAI model can hallucinate, huh? So there are different ways. We will be going through in detail the how to reduce the hallucination and all from the GenAI models. So there are certain optimization techniques that we will be learning. So that will improve the accuracy what we got from the GenAI models, huh? Are you able to get the overview how the things are happening? Is it, or some more doubts are there? If you are having something in your mind, you can ask, huh? Swati, I think Swati was there, huh?
Yes, sir.
uh, do you have any query with respect to that, huh? Like fine tuning, you can take it in this particular way, Swati, huh? Fine tuning and sorry, pre-training, fine tuning, and the users, huh? Okay, so pre-training, huge infra, and once we are getting the outcome from the pre-training models, it is not the optimized one, huh? We can get, uh, you can say, weird outcome from the pre-trained models, huh? Then fine tuning is being happening. Okay, and it will provide, say, 100K of questions being asked to the model in order to provide the output, and then the users, huh? Okay, so over here, huge infra, limited infra, and once we're talking about the users and all. Okay, so over here there are two things, the infra at the user side, and then the infra at the server side, say the application where the application is deployed, say GPT-4, GPT-4. So the infra with respect to the GPT-4 servers, that will depend the simultaneous users, say if they are having 10 users, then small infra is fine, which will be able to handle the GPT-4 deployment. And if 10 users, small infra, and if they are having say millions of users, then infra will be depending upon the simultaneous users. So you can probably you are having the idea the infra time and cost. This is not calculated based upon the single stuff. Okay, there are multiple points, there are multiple, you can say, key factors which need to be taken into consideration once we are talking about the infra cost accuracy and and time. So multiple factors are there. Without benchmarking, let me talk specifically, without benchmarking, you will never be able to compute that this is the time in GPT-4. This is the time if I'm running the Llama 4 model or Llama 2, Llama 3 model, right? Are you able to get? So yes, we can optimize. Say if you are saying that I'm taking 3 hours with this much of say users in order to get the response from the GPT-4. So what I need to do, then I can say if you are having this much of infra, you are having this much of users, then you need to add this much of the resource, or you can do something like say have different database, change the database and all. Okay, so there are different things in order to have the optimization, but blindly we can't say that for this particular model we need to have this much of infra and all. Okay, so that is the thing. Yes, from the user perspective, in order to learn the GPT GenAI stuff, the machine will say the the i5 processor with 16 GB of the RAM, we will be able to learn. But if you are talking about pre-training and the the fine tuning, that requires huge infra, right? Is there anything in your mind? Friend, any question, anyone having any doubt, any confusion, what they are not able to get? Guys, say yes or no. Are you are you with me? All of you, are you with me?
Yes, all good.
Yes, sir.
Okay, okay, okay. So, so let's talk. Let's communicate with each other. So, what you are able to understand from today's session? Starting with Rohit, then Vikas, then Lakshmi, Tejas. Okay. So how the name are displayed on my screen, we will have discussion. So Rohit, what did you get?
Yeah. So for this one, we are getting that all the priorities are giving to the matrix-based calculation. So whenever you are predicting something, so AI is predicting on the basis of this mathematically calculation and on the basis of this matrix. So whatever is the most nearby answer, it is predicting that one. So it's totally based on the calculation on that one. And
Mm-hmm.
accordingly the infra that we are providing to the models, it's totally depend on the data and the number of users as well.
Mm-hmm. Okay. Vikas, what did you get? Vikas, Swati.
Sir, onto the understanding, the complete prediction is depending upon the distance calculation, and the distance calculation is done in different ways, like dot product is there, Euclidean distance is there, and other than this, how we are predicting is the execution and everything will be depending upon different parameters, like your parameter is there, features are there, and then your tensors and scalars are there, that will be basically helping you to get the required output in a better format, and to get the execution and speed, and we will be basically using the infra for getting a better speed and all. So this much I got.
Kunal, try. Kunal, Vijay.
Yeah, sir, it's the same. Like we have learned about the scalar tensor, how is it working, and we also learned today how to calculate the distance between the each tokens as according to the angles, distance. Okay, how they are communicating, and we have learned about the dot product as well as the Euclidean distance, and dot product is much preferred as compared to the Euclidean distance to calculate the distance between each token, and also that during the pre-training much of the infrastructure using as compared to the fine-tuning. And one thing, sir, do means very less company has doing the pre-training, because every company have not the much infrastructure. So pre-training, when it is converted into the foundation model, so it the open source, or it is also the paid for the new company to convert it into the fine tuning?
Depending upon organization to organization, na? Okay, most of the organizations have provided the open source models. What we are able to see onto the Hugging Face, that is nothing but the open source models they have created, and open source them. Okay, but it is completely the organization decision how they are going to provide the model. Like GPT-4 is there, huh? So they have not open sourced it. They are asking for the, you can say, chat GPT-4, which is inside this the foundation model is there, huh? So they ask for the membership and all, right? So depending upon organization to organization, even the Grook.ai, they are having some, you can say, premium models. So for those particular models, you need to purchase the membership plan and all, right?
Yes.
Yes, I got it.
Okay, so it will depends. So we, whatever we are covering, that is good uh, for your understanding, in order to get the internals. And probably once you face the interview, then it might be possible certain interviewer will ask these particular questions, what is happening internally inside the transformer architecture. Okay, so from that perspective, from understanding perspective, okay, these particular things are necessary, and that's why like we are going through with these particular things, huh? Although like I can skip these particular things, but uh, from understanding perspective of what I thought, like these things should be described in a better way, so you will be able to get the basics. And once basics are strong, then you will be able to understand. You will be having the broader horizons, in order to get the things, consume the things. Okay, so I think that's it for this particular session, huh? Okay, tomorrow we will be having more discussions, and we will see something from the practical perspective as well, huh? If you are having anything, if you want